Talk about finding the area of a trapezoid and a rhombus. We'll start out first with a trapezoid. I'm going to come up and show you how the formula came about by doing a little demonstration here. Move this aside. And what I did was I have a trapezoid like that. Okay. And maybe the light's too bright on here. Okay, that'll work. And so we know that in a trapezoid, let's call that base 1 and that base 2. Okay, and I'll put let's call this angle A and this angle B. What I did was I cut out an identical trapezoid, this one like this, and I'll label it the same way. Base 1, base 2, this is angle A, this is angle B. To find the area of this trapezoid, what I'm going to do is take these two, and I'm just going to take this copy and turn it upside down until it matches up right there. Okay, and what we just created was a parallelogram. Now previously we know that the area of a parallelogram is the length of the base times its height, right? Okay, and so if we were to look at this problem, the length of the base is base, whatever base 1 was, that's what this is right here, was this length up here, because I turned it upside down. So this whole length is base 1 plus base 2. In other words, these two bases added together. The height is the perpendicular distance down here from here down to here. That's the height of the trapezoid. So the area of this whole thing is base 1 plus base 2 times the height. But we wanted the area of just one of these. So the area of one of these, since these are identical, I would take that and divide it by 2. And so that's where the formula for the area of a trapezoid came from. The formula is area is 1/2 times the height times the sum of the bases. Base 1 plus base 2 times the height divided by 2 or times 1/2, either way. And so if I gave you an example, we had a trapezoid, let's say that this was 6 inches, this was 9 inches, and this distance right here was 4 inches. So it doesn't matter, we just add the bases. I don't care which one is 1 and 2. The area of this then is going to be 1/2 times the height, which is 4, times the sum of these two, times 9 plus 6. And that's going to be inches squared, because area is always units squared. So then you work that out. This is 15. 4 times 15 is 60. And 60 times 1/2 is 30. So the area of that trapezoid is 30 square inches. Okay? That's really what there is to finding the area of a trapezoid. For a rhombus, if you remember what a rhombus is just a four-sided quadrilateral where all four sides are congruent, they're the same length. Okay? And through mathematics we can show, but I'm not going to because it takes way too long to do it. We have two diagonals. We got a long diagonal, I'll call that diagonal 1, and then we have this diagonal, which I'll call diagonal 2. The area of that trapezoid or of that rhombus is only dependent on those two things. I really don't care what length the side is. So if it's 1/2 diagonal 1 times diagonal 2. And that's the area of that rhombus. So if they gave you what those diagonals are, multiply them together and divide by 2. So if we had a rhombus that had, say this whole thing was 10. Well, here, let's do a couple examples. Let's do one real quick here. Let's say I had this rhombus that there's the two diagonals. Let's say I told you that this was 6 and this was 4. Okay, so this length right here is 6. So that means this whole diagonal has a length of 12. This is 4. This has a length of 8 then, because diagonals bisect each other in rhombus. So I know that then the area of this is going to be 1/2 8 times 12. And if this was, say, centimeters, it would be centimeters squared. So you multiply it out, 8 times 12 is 96. Half of 96 is 48 square centimeters. And there's your answer for that one. Okay. Now on the worksheet today, it also talks about on the back, on the second page, it talks about kites. We didn't really talk about what a kite was before. You all have an idea of kite are the things you fly up in the air, right? So the definition of what a kite is it's where consecutive sides, these two sides have the same length, and these two sides have the same length. Okay? And again, it's made up of two diagonals. The diagonals bisect, this diagonal bisects this one. So whatever this length is, this is the same. They're perpendicular to each other. Okay? Call this diagonal 1, let's say that's the whole length, diagonal 1. Diagonal 2 is this one across here. The area of a kite then is just 1/2 diagonal 1 times diagonal 2. So as an example, if we had a kite that, let's say they gave me that this length was 20 millimeters, and this length from here to here was 6 millimeters. We want to find the area of that kite. So the area is just 1/2 of 20 times 6, and that would be millimeters squared. So 20 times 6 is 120. Half of 120 is 60 square millimeters, or millimeters squared. And that's what the assignment is today. Now on the worksheet for today, there's several other problems. All I want you to do is on the front page do problems 1 through 4, and on the second page do problems 1 through 4. Don't do any of the ones where they give you the area and ask you to find the missing parts.